In this video, I'd like to have a conversation regarding sound, specifically solving this particular word problem here. And it says here, the threshold of pain is about 120 decibels. How many times greater in intensity, in units of watts per square meter, is this? Well, we need to decipher this question a little bit. So I'm going to draw a picture of an ear. Here's an ear. A human ear. And the minimum that we can hear, I'll just write down the minimum that we can hear, in terms of intensity, it has the symbol I naught. And the maximum that we can hear, or all of the other intensities above I naught, will have the symbol I. So I'm just going to call the maximum we can hear I. I could put a subscript in here, I maximum, or I1, or I2. It doesn't matter. Something above I naught. In our case, it's going to be the maximum. Now, I naught, this here is I sub 0. It's pronounced I naught. And the word naught, 0 in the Old English, I naught. In Old English, 0 used to be called naught. They're written like this in Old English. So instead, we could call this I sub 0. Often in physics, this is simply pronounced I naught. And I naught is typically the beginning in most equations. So here is the beginning of hearing. And then we can hear all the other intensities in between up to a maximum. And this will be the pain threshold. Pain threshold. And we want to find I. Looking at this word problem, it says the pain threshold is about 120 decibels. So we're given a sound level of 120 decibels, such that the range in terms of decibels from here to there is 120 decibels. But we're asked to find the intensity here, find I, at the maximum, in terms of watts per meter squared. This is what we want to find. And I'll put a question mark there. We know I naught, simply from literature. I naught has a value of, this is the threshold of hearing, has a value of 1 times 10 to the minus 12 watts per meter squared. And this comes from the literature. So we know I naught. We want to find I if the sound level being measured is 120 decibels. Okay, let's have a look at our equation. Sound level equation. Sound level, I'll represent that as SL. And sound level has units of decibels, is equal to log base 10 of 1 intensity in the numerator in terms of watts per square meter divided by I naught in terms of watts per square meter. So let's rewrite this and put in some of the numbers that we know. We know the sound level given to us in decibels is 120. So 120 decibels is equal to log base 10. I is what we want to find. Here's our I that we want to find. In terms of watts per square meter, so I'll just leave it as I. Divided by I naught. I naught we know. 1 times 10 to the minus 12. And has units of watts per square meter. Oh, my equation, my error, this has a 10 in the front. My error. So it's 10 log of this argument, 10 times this. Moving on, let's remove the 10 from here and bring it over to the left-hand side. 120 decibels divided by 10 is equal to log base 10 current divided by 1 times 10 to the minus 12 watts per meter squared. And here we have watts per meter squared on the right-hand side and decibels on the left-hand side. That doesn't make sense. If you see a previous video of mine, decibels here was basically inserted here by agreement. So we're just going to remove it. And so this equation then will look like, we'll take the 120 divided by the 10. That's 12 is equal to log base 10. I is what we want to find, divided by the I naught in terms of watts per meter squared. Having said this, we need to now find I, but I is inside the argument for a logarithm. And logarithms are similar to, or equated to, exponentials. There's a relationship between logarithms and exponentials. And let's see what that relationship is. I have here calculus book, one that I consider to be the best calculus book ever written. And the author, if I can scoot him down here, nope. On the inside jacket of this particular textbook is, well, it's a whole bunch of calculus here. We'll go to the back inside jacket. Yeah, here we go. And we're interested in logarithms. Let me just zoom in a little bit on that. And we're interested in this relationship here in the beginning. Y is equal to log base A, and the argument is x. Log x, base A, means, and this is changing logarithms into exponentials, a to the, is that so small? A to the y equals x. I'm going to rewrite this, and this is what we're going to use in order to solve our problem. Let me rewrite that. Over here, oh, just zoom back down a little bit. And that relationship was y is equal to log base A of x. And that means, in terms of exponentials, A to the power of y is equal to x. Looking at our equation and this format here, y represents the 12. Log, well, that log is the log. Base A, that'll be the 10. And x is this entire argument in the bracket. So let's change this into this form. A is 10. Y is the 12. Is equal to x. And x, we said, is this whole argument right here, this fraction. I is what we want to find, divided by 1 times 10 to the minus 12 watts per square meter. Now we have just a simple algebraic equation, and we need to solve for one variable, I. To do that, we're going to multiply both sides times 10 to the minus 12, 1 times 10 to the minus 12, multiply this 1 times 10 to the minus 12, and then whatever we do to the right, we have to do to the left-hand side. I'll do that here just to show it to you. 1 times 10 to the minus 12. Wherever the number goes, the units goes with it. And whatever I do to the right, I have to do to the left, so I'll just write it over here. 1 times 10 to the minus 12 watts per square meter. These two will cancel out, effectively putting this over here to the left-hand side. Rewriting this, cleaning it up a little bit. 1 times 10 to the minus 12 times 10 to the positive 12 is equal to I. So let's put this in our calculator and let's see what we get. Oh, can't forget those units, watts per meter squared. And the value comes to, when we put this in our calculator, and it's 1 exponential minus 12 times, and this is the same as writing 1 time 10 to the power of 12. That's what that represents. So I'm just going to put that in my calculator. 1 times 10 to the power of 12. 1 exponential 12 equals. And the answer is 1. And the unit is watt per square meter is equal to the intensity. And this intensity is what we have found. Go back to my little diagram here. So I naught is 1 times 10 to the minus 12 watts per square meter, and I here after 120 decibels, 120 decibels up in sound level, that I becomes, according to our equation, 1 watt per square meter. And let's go back to this, doing a little bit of math right here. We already have, and I'm going to ignore the watt per square meter, just do the math. We already have this value, 1 times 10 to the minus 12. And 10 to the power of 12 is also, this is just shortened 10 to the power of 12. In order to do this, we multiply the two coefficients. 1 times 1 is 1. And 10 to the power of minus 12 times 10 to the power of 12. The way to multiply those, you add the exponents. 10 to the power of minus 12 plus 12. This is equal to 1 times 10 to the power of minus 12 plus 12 is a 0. And 10 to the power of 0, any number to the power of 0 is 1. 1 times 1. 1 times 1 equals 1. And that was our answer using our calculator, putting in the units to be watt per square meter.